I'm Anil Kumar. Welcome to my YouTube channel and the new website which is under development, Global Math Institute. Let me thank Lisa, one of our subscribers, for sharing this very important worksheet based on Vectors Unit 1, Introduction to Vectors, with us. The whole idea here is to provide you with solution of the worksheet, share it with all the students, and I'm going to place the worksheets, test papers shared by students on my website as a reference resource, free for all times to come for all the students. So Lisa, once again, thanks a lot for sharing these questions with us, and I hope many will benefit. Now recently I just had a fracture. I'm still coping up with the recovery. So let me thank all my students who are helping me out in making the video. So they are my cameramen and they help me out in many things. So my handwriting may not be as good as it should have been. However, I'll try my best. So I hope you can see the first three questions now. I'd like you to pause the video, copy these questions, solve them. Also make a note of other questions on this worksheet. There are 10. So these are question number 4 to 6, and then we have the last three questions, questions 7 to 10. Let us now take the solution of these questions one by one. The very first one is, a camera is suspended by two wires over a football field to get shots of the action from above. At one point, the camera is closer to the left side of the field. The tension in the wire on the left is 1500 newtons and the tension in the wire on the right is 800 newtons. The angle between the two wires is 130 degrees. Determine the approximate magnitude and direction of the resultant force. So let us see how to solve such a question. Okay. So let's make the diagram to illustrate this situation. So let's say that is the bar from where we are suspending the two cameras. One of them is shorter, the other one is longer. So we'll make one shorter and the other one longer. Okay. Now we are given that the tension in the wire on the left is 1500. So we'll say this is 1500 newtons, right? And this one is 800 newtons. And the angle in between is 130 degrees. Okay, that is the situation. Now the camera is placed right there. So the camera can be shown like this. So the force of camera is towards downwards, the gravitational force. The tensions here are in these directions, correct? Now, all these forces can be represented in the form of a diagram, which we will call the force or the vector diagram. Now, first thing which we need to understand is how to actually draw that diagram, which can help us find the resolution and the solution of this question. So to keep it in equilibrium, we need to have a force which is equal and opposite to the force of the camera. So that equal and opposite force can be shown by this arrow, the vector going upwards, right? So this is your resultant force, right? So this is, we'll call this as our resultant force, which we need to figure out. Right? Now this force is actually equal and opposite to the force given there. To make a triangle, what we do is we draw lines just parallel to and equal to shown in the diagram. So here, this is the line. So from here we can draw a line here which is parallel to 1500 Newton tension, and let's say there you go, right? So let's say this is our 1500 Newton tension. Okay. And the other going towards parallel to 800, so we go like this. It does make sense to you, right? So the diagram is not very accurate, but it does give you a glimpse of idea, rather, how to actually sketch the diagrams. Now these are the tensions, correct? Critical part here is to work out the angle in between. This angle. Do you see that? So if I draw a horizontal line here, then we know that this part of the angle, let us say which is x, is same as this part which is x. Is that correct? Perfect. And this part of the angle is y, correct? So that should be y for us. The combination is you need to add x and y. Now from this diagram, it is, I think, absolutely clear what should be x plus y equal to. So we can clearly say that x plus y should be equal to 180 degrees minus the angle 130 given in between. And that gives you 50 degrees. So this angle in between is 50 degrees. Do you get the idea? Now if you write down 130 degrees here, you're going to get wrong result, which is going to be much higher than the actual resultant force. Perfect. So this is a mistake which should be avoided. Now we have two sides, we know them. If you look into the triangle, one representing 800 newtons, the other one representing 1500 newtons. We know the angle in between. So whenever that is the situation, you can always use cosine law. Since the situation is SAS. Perfect. And from here, we know what resultant is. We can say resultant square is equal to 1500 square plus 800 square minus 2 times AB, which is 1500, times 800 times cos of angle. Cos of angle. Angle is 50 degrees, not 130 degrees. Does it make sense to you? Right? So we can just calculate these values now. So it's basic application of cosine law. So we have 1500 square plus 800 square minus 2 times 1500 times 800 times cos of angle 50 degrees, and we get a value which is pretty big value, right? So we get r square is 1347 309.7. So r is basically square root of this. So let's do square root of our answer, and we get a value which is equal to 1160.7 newtons. So that is how the first question should be solved. Perfect. So we have the magnitude of this resultant force. So we can now write down our answer that the resultant is vertically upwards with magnitude of 1160.7 newtons. Is that clear to you? Perfect. So I hope the solution is absolutely clear. Now let's take the second question. Three forces act on a body. The force of 100 Newton acts towards the north, a force of 120 Newton acts towards east, and a force of 90 Newtons acts at north 20 degrees east. Determine the resultant. So let's say that we have our forces. So let me draw a coordinate plane here representing east, west, north, and south. And on this, we are going to plot the forces. A force of 100 newtons right, is acting towards the north. Let's say this is north, 100 newtons. Okay. 120 newtons east. So slightly longer than 100. So that makes it 120, and that is 100. And then we have a force of 90 newtons, which is acting at, it is from north 20 degrees east. So this angle has to be 20 degrees, correct? Towards east, and so that is the force. You get the idea, right? So this is 20 degrees. And this force is 90 newtons. Is that clear to you? So we have shown the forces here. Now there are a couple of ways to solve this particular question. Now the approach which I am going to take is we are going to resolve the forces in x and y directions, right? So this is our y direction, that is our x direction, and that will be our origin. Right? So we'll resolve forces in x component, we'll call it f of x, and y component, f of y. Is that clear to you? Correct? So here we already have the two forces which are in x and y direction. The only thing which we need to take care of is the 90 Newton force, which is 20 degrees east of north. So clearly from here, the x component of the force is 120 newtons, right, plus 90. Now which component? X in the direction of horizontal direction. So if you look at this angle of 20 degrees, we can resolve like this. Do you see that? So that becomes, and this side here is opposite to 20. So since it is opposite to 20, it is a sine component, right? So it is lesser than 90 and a sine of 20 degrees. The vertical component is not contributing in the horizontal force. The y components here, 120 will not contribute, but 100%. Plus 90, the force along the y-axis is the base of this triangle, adjacent side, right? So it is 90 cos of 20 degrees. So I hope that is absolutely clear. So let's calculate these values, right? So we have 90 times sine of 20 degrees, and to this we'll add 120 to get the x component. So we get 150.78, right? The next one is 100 plus 90 times cos 20, and that is 184.57. So these are your forces, x and y components, right? So we can actually, the net force which we have got is kind of like this. So we have a force which is x component of 150, and we have a y component of 184, slightly longer. So the effect of this is the resultant force which will be in this dash. Is that clear to you? Now this resultant force is at an angle theta to the horizontal. We need to normally find that angle, right? We'll do 90 minus theta, okay. And we figure out that this x component is 150.78, the y component is 184.57. So from here we can say, what is tan theta? Well, tan theta is equal to 184.57 over 150.78. So theta is tan inverse of all this. So let's find this. So we'll do tan inverse of 184.57 divided by 150.78. That gives us 50.75. degrees. Now note, if you have to describe this the fashion given here, there are different ways, right? You can write it as a bearing angle, but good way is always to write the angle from the north, right? So we have to figure out what is this angle from the north. So that angle from the north, let's call this as the angle phi. So the angle phi is 90 degrees minus 50.75 degrees. So let's take away from 90 our answer, right? So we'll do minus 90 and then write down 39.24. So we can approximate this as the angle 39.2 degrees, right? So that becomes the angle of our resultant. Now let's also find the magnitude of the resultant. So the resultant force will be what? These are the two components, right? So it is f of x square plus f of y square, right? Since that is the right triangle, right? This is a right triangle. We got x and y component, theta. So, so for this right triangle, it will be f of x square plus f of y square, and that is, we have 150.78 square plus 184.57 square, right? Square root. So let's do this calculation. So we have square root of 150.78 square plus 184.57 square equals to 238.32. We can approximate this to 238.3. Okay? The units, of course, will be newtons. So now we can write down our answer. That is, the resultant is 238.3 newtons, and the angle is from north, we have 39.2 degrees east. Okay? So that is how you should be solving this. I hope that makes sense. Now let's look into question number 3. Question number 3. A ship's course is set at a heading of 143 degrees at 18 knots. A 10 knot current flows at a bearing of 112 degrees. What is ground velocity of the ship? So let's try to understand these angles, the bearing angles, and then we'll actually solve this question, correct? So let me first share with you, when we say the ship's course is set at a heading of 143 degrees, it means what? This is always taken from the north, right? 143 means what? 90 plus 53 degrees, right? So we can say from here 143 degrees, right? So this component of the vector can represent 18 knots. You get an idea, right? So this is our 143 degrees in all. Now if that is 143 degrees, then how much is this? Well, this is 90 plus 53, right? So you can take away, so it is 53 degrees. You can actually resolve and just see that. Okay. So that is one component. The other one is a 10 knot current flows at a bearing of 112 degrees. So 112 is also greater than 90, right? So 90 plus 22, right? So it is kind of like this, slightly less. Let's go like this. And little smaller than this. Okay. So we have these two components, that being the wind, right? Which is 18 knots. And this is 100, this is 18 knots, and that is 10 knots, okay. Okay. So these are the two components. We need to find the resultant, correct? So let's make our diagram to figure out the resultant. So we'll again make our reference frame, the coordinate plane, and then, so both will do it here. So we have this component of ship's course, which is at an angle of 143 degrees. And then we have this current, now which is 112, right? So this is that component. So we'll add this to the head, and there it goes. Correct. The resultant, of course, will be from the origin to this point, right? So we are making a free sketch here, and that is how you could do in your test paper also, right? So that represents the ground velocity, right? So we'll call this as our ground velocity Vg. Correct? Now Vs, ship, and that becomes our wind velocity. Now from this diagram, it is critical to find the angle in between the two velocities given to us. How do we figure this out? So you can think about your coordinate plane once again here. Now we are looking for the combination of these two angles, right? Correct? So how do you find this? One way is, we know that this particular angle with 90 degrees, we have that component here. Okay. And this is that smaller angle shown here, right? So this smaller angle is, let's work out here, 112. This angle is basically 112 degrees, take away 90 degrees, correct? So which is 22 degrees, correct? So we have the angle of 22 degrees with the horizontal. Now let us try to understand the strategy to find that angle. As you can see from here, we need to figure out what this angle is. Now this angle here is 180 degrees, take away 143, right? So that is 37 degrees. Now this angle is same as the angle here, right? So with the vertical, it makes 37 degrees. Do you see that? These two angles are equal, right? Now we have a 90 degree in between. So the angle in between these is, so we have, let's write on. So the velocity of the ship is given to us as 18. Velocity of the wind is given to us as 10. I'm not writing the units. And the angle in between, as shown here, is 37 plus 90 plus 22. Correct? So that is the angle in between. So let's add this up. 9 and 11 and this 14. 149 degrees. Is that clear to you? So that is how you can find the angle in between. Correct? Okay. Now, to find the resultant, we can again use the cosine law. Is that clear to you? So this time I'll directly write down the formula. We worked it out in the very first example in greater details. So Vg will be equal to square root of squares of these two. So we have 18 square plus 10 square minus 2 times 18 times 10 times cos of the angle in between, which is 149 degrees. So that becomes the component of resultant. So we have square root of 18 square plus 10 square minus 2 times 18 times 10 times cos of the angle 149. This value is 27.06, which we can approximate to 27.1 knots. So we have the magnitude of this, right? You can say magnitude, right? Okay, no problems. Now we need to find the direction. So to find the direction, let's say this angle, we call this angle as alpha, for example. We can use sine law, right? So to find the direction, okay. So we can say sine alpha over the side opposite is represented by 10 equals to this angle in between is sine of 149 degrees over the resultant which we just calculated. I'll write 27.06 here. Okay. It's better to actually use 4 digits if possible. So from here we can say sine alpha is equal to 10 over 27.06 sine of 149 degrees. Correct? Let's figure this out. So we'll find alpha as sine inverse. So we get alpha as, we'll do sine inverse, first calculate. So we have 10 divided by 27.06 times sine 149. So this is, we'll do sine inverse of that angle. This is 0.1903. Right? So that was 0.19033. Correct. So we'll do shift sine inverse of our answer, and which is equal to 10.97. Okay. So that can be rounded to 11.0 degrees. So this is 11.0 degrees. That is the alpha, right? And we also note that so we have to find the total angle. When we have to report this, we need to write down the bearing angle. Is it okay? So that is a bearing angle which we want to write for the resultant. So we know that this particular angle here is 37 degrees. So this is 37 degrees. Let's work this out. And that small angle here is 11 degrees. So the angle which we're talking about is 90 plus, it's better to write from 180 minus, right? So we'll do 180 minus these two. So let me write down. So the angle theta, let's say, so the angle theta will be 180 degrees, take away 37, take away 11 degrees. Does make sense? This is simpler. So we have here 180 minus 37 minus 11. 132 degrees. That is good. Is that clear to you? So we added these two angles and took away from 180 degrees. Okay? So clearly, our answer here is The ground velocity, so we say Vg, is the magnitude we wrote 27.1 knot. At a bearing of 132 degrees. Right? So that is how we could answer this. So I hope this is absolutely clear. Perfect. So let's move on and take the next question. So question number 4 has two parts, A and B. Write each force as an algebraic vector in component forms. So the first one here is 500 newtons applied at 30 degrees to the horizontal. Okay. So let me just sketch the plane here, right? So we have this plane. We are saying we have 500 newtons at 30 degrees to the horizontal. So that is 500 newtons. And this is at 30 degrees to the horizontal. So it will have two components, x and y. So this is x component, that is the y component. So we can write f of x, fx rather, this is 500 newtons, will be the cos component. So 500 cos of 30 degrees, and the y component will be the sine component, 500 sine of 30 degrees. You can always use your special triangles in such cases, right? So let me just sketch one special triangle here, which will be 1, 2, square root 3. We're talking about 30 degrees, which is right there. Right? So the cos component is square root 3 over 2, right? Or 500, right? So which is equal to, let me write now, 250 square root 3 units will be newtons. The other component will be a 500 half, right, times half, which will be 250 newtons. So we have our answer that the forces, write each force as an algebraic vector in components form, right? So it could be in the component form, the force F is equal to, you can write this as f of x equals to 250 square root 3 newtons, and f of y, fy I should say, not f of 250 newtons. Is that clear? Okay. Part B. It is straight. We are saying 25 newtons applied downwards, right? So in this particular case, it is 25 newtons applied downwards. Downward force will be referred to as negative, right? So we can write this f of x is 0 newtons and fy is minus 25 newtons, right? Since it is acting downwards. Is that clear to you? So that is how we can answer this question. Correct? 5 from the worksheet is solve for x. Vector u equals to x comma 3x and the magnitude of vector u is 9. B. Vector u is 2x comma x, vector v is 5xx, and the magnitude of u plus v is 6. C is vector u is 3x 7, y is 5xx, and the sum of magnitude of u and v is 10x. Now you need to solve for the value of x in this particular question. You can always pause the video, answer the question, and then look into my suggestions. So let's begin with the very first one. We are given u equals to, the vector u is x3x. And we are also given that the magnitude of vector u is 9. Now, if a vector is given and its magnitude is given, what is the magnitude of the vector? Well, the magnitude of vector u is basically, for this vector, will be square root of x square plus 3x whole square, right? So that is what the magnitude should be. Now this magnitude is given to us as 9. So we can equate this to 9. And now we have an equation in x which can be solved. So let's square both sides. So we get x squared plus 3x whole square equals to 9 squared. So that is x squared plus 10x squared equals to 81. And this is, 9x squared I just added. So this is 9 plus 1, 10x squared equals to 81, or x squared is 81 over 10. Now it is a good practice to always write the answers with rationalized terms, right? So here we can now solve for x. So x is equal to square root of 81 over 10 with plus and minus sign. So this could be written as plus or minus 9 over square root of 10. Now that can be rationalized, right? So we should rationalize and write it as plus or minus 9 over square root 10 times square root 10 over square root 10. So now denominator is 10 and the numerator is 9 plus minus square root 10 over 10. Is that clear to you? So the value of x in this particular case is plus or minus 9 square root 10 over 10. So I hope the steps are absolutely clear. So the basic concept which we have used here is that if the vector u is AB, then the magnitude of vector u is square root of a square plus b square, correct? Now let's take up part B of this particular question. In part B, we are given two vectors and the sum of these vectors is 6. So let us find the sum of the vectors first. So we are given the vector u as 2xx, vector v as 5xx, correct? So vector u plus vector v will be what? It will be 2x plus 5x and the y components x plus x, which we can write as 7x 2x. So that is vector u plus v. What is the magnitude of this vector? Well, the magnitude of this vector will be square root of 7x whole square plus 2x whole square, right? Now this magnitude is given to us as 6, right? So we can write this as 6 is equal to square root of 49x squared plus 4x squared. Now we can square both sides and solve just as we did last time. Perfect. At this stage, you can always pause the video, further solve the question, and then look into my suggestions. So we can write this as 6 squared equal to 49 plus, I'm just writing 49x squared plus 4x squared. So we have 36 equal to 53x squared, or we can write 36 over 53 as equal to x squared. And so we can write x as square root with a plus minus sign of 36 over 53, which is plus minus 6 over square root of 53. As we did last time, we'll rationalize the denominator, and so we'll write x as plus minus 6 over square root 53. You multiply and divide by square root 53, and you get 53 in the denominator. Is that clear to you? Perfect. So that is how it should be solved. I hope the steps are absolutely clear. You can now pause the video and answer part C yourself. That should be easy, right? Here is my solution. Now let's take up 5c. We're given these two vectors. Vector u is 3x7. Vector v is 5xx. Their sum, vector u plus vector v, is going to be, we'll add these components, 8x, and then we have 7 plus x, correct? So that becomes the sum of this vector. Now, magnitude of this sum is what? Magnitude of u plus v will be square root of 8x whole square plus 7 plus x whole square, correct? Now it's a good idea to also write this as, you can always write this as square of this magnitude, right? Equal to all this. So let me write this as 64x square plus, let's expand this, 49 plus 2ab, which is 14x plus x square. The magnitude is given to us as 10x, right? So we are also given that the magnitude u plus v is equal to 10x. So we'll replace this with 10x whole square equal to all this, right? So 64 plus x is 65x square, and we have 14x plus 49. Here we have 100x square, right? Let's take away 65 x squared. Let's take away 14x and 49. It gives us a quadratic equation, correct? So we may have to use the calculator now to solve this question, correct? So we get 35 x squared minus 14x minus 49 equal to 0. So now let's use, you can use quadratic formula to find the solution. Or we need sum and product also you could do. But anyway, we'll use the quadratic formula to find the solution. So x equals to minus of 14, which is 14 now, plus or minus square root of 14 square minus 4 times, so quadratic formula, 35 times minus 49, correct, square root, over 2 times 35, correct? So we get the value of x as 14 plus minus square root of all this, which is 14 square plus 4 times 35 times 49, right, that minus minus over 70. Let's calculate this using a calculator. So within square root, we have 14 square plus 4 times 35 times 49, and that is 84. So we can write this as 14 plus minus 84 over 70, right? So we get two solutions here. So if I do plus 14 and then divide by 70, I get my answer as 1, 2 over 5, which is 7 over 5. And if I say 14 minus 84 and then divide by 70, I get minus 1. So we have two solutions for this. The solutions are, let me write down here, the value of x is equal to 7 over 5 or minus 1, correct? So these are the two solutions for the third part. So I hope with this you clearly understand how to find the value of x using the dot product or understanding the magnitude of vectors or their sums. So I hope the solutions up to question number 5 are absolutely clear. We'll take a short break now and then continue with the rest of the solutions. Feel free to write your comment, share your views, and keep sharing with us. Thanks for watching and all the best.